Hello everyone, today we will be presenting our coursework 1, California Housing Project. The goal of this notebook is to predict median house value using linear regression with some feature engineering and pre-processing along the way. We will highlight the strengths, point out the main issues, and show the fixes we have made. First, what the code does. The workflow is pretty straightforward. Load the California housing dataset, perform exploratory data analysis to understand the distributions and correlations. Third is engineer some extra features such as ratios and polynomial terms. Fourth is pre-process the data and train a linear regression model. Fifth is evaluate the results and look at feature importance. So the strengths of the notebook is the notebook has already a nice flow from data exploration to modeling. The features chosen, like income and room related ratios, make sense and are interpretable. There are also useful visualizations such as scatter plots and heat maps that help explain the data before modeling. Key issues found first is data leakage.
Pakihinaan,
Some
please.
pre-processing steps were applied to the entire data before splitting into train and test. This leaks information from the test set into the training process and leads to overly optimistic results. Target confusion. At one point, the target variable y was accidentally set to a feature like median income instead of median house value that breaks the whole modeling logic. Inconsistent preprocessing. Scaling and encoding were done separately for train and test, which can introduce inconsistencies. Fourth is evaluation robustness. The notebook relied on a single train test split. This can be misleading because the results depend too much on one split. So the fixes applied. All pre-processing and feature engineering steps are now wrapped inside a single pipeline with a column transformer. This prevents leakage and guarantees consistent transforms. Next is the target is explicitly set to medhouse val, with assertions to double check that it's correct. We added a five-fold cross-validation setup with both R squared and RMSE, plus a clean holdout test for a fair evaluation. Feature engineering is handled safely in the pipeline. Ratio features polynomial terms for income and rooms and geographic means using k-beans discretizer. For, for interpretability, the script now prints out the top standardized coefficients ranked by importance. Finally, reproducibility is improved with random state is equal to 42, deterministic CV, and the structured Python script. The clean pipeline improves model performance. R squared goes up and RMSE goes down compared to the baseline. The top drivers of house value are still intuitive: income, room ratios, and location means. But now the results are reliable and leak-free. And next is debugging by Jetro Cortez.
So the first debugging exercise we identified is the use of the Python debugger in the code. There is a line import PDB. This tells us that we are expected to use pdb.set underscore trace to pause the program and inspect variables step by step. This exercise is meant to train us in interactive debugging, so we can stop the program at specific points and check the state of our variables when errors occur. The second debugging exercise is related to how the dataset is accessed. The code uses x equals data frame dot drop, parenthesis columns equals bracket med house val, and Y data frame Medhouse val. This can cause errors because data is actually a bunch object, and depending on the scikit-learn version, data.frame may not exist. The correct way is to make sure we're using the attribute provided when asFrame is equal true, or convert the dataset into a data frame manually. Debugging here requires us to check the attributes of data and fix how we extract the features and target. The third debugging exercise involves the correlation matrix. Yeah. Here, the core equal data.frame.core. This can also fail for the same reason. The data object doesn't always have a frame attribute. The fix would be to use the actual data frame containing the dataset. For example, core equals x dot join y dot core. Then the correlation heat map will work correctly. This exercise highlights the importance of understanding the data structure and correcting method calls. To summarize, the three debugging exercises involve using the Python debugger PDB for inspection, fixing incorrect dataset attribute usage, and correcting correlation matrix calls. And that concludes the debugging part. Now we move to Rupert to discuss the results.
Baba mo nga dyan.
Hmm?
Baba mo sa ano, sa may, ano na,
Okay. Sige.
yung MSE. Sige pa. Pwede na dyan, pwede na dyan. Okay, so in this part of the project, we focus on feature engineering with the help of AI. The goal was to improve the predictive power of the model by creating new features, transforming existing ones, and ensuring the data was well prepared for training. With AI's assistance, we generated ratios of existing features to capture relationships between variables. We applied one-hot encoding. Hanapin mo nga dyan, one-hot encoding. Uh, and we applied one-hot encoding to categorical features so the model could use them effectively. We also created a polynomial features to capture more complex and nonlinear patterns. AI also helped us detect and address outliers that could bias the results. And we also used scaling and standardization on the numerical features to keep everything on the same level. Tapos, dun sa ano legit, sa MSE. Yan. Next is we trained a linear regression model using scikit-learn and also with the guidance of AI. We split the data into training and validation sets and then evaluated the model using mean squared error and R squared. The two models were compared. Baseline model was trained on the original features only. Baba mo dyan. Baseline. And the engineered model was trained after applying AI-assisted feature engineering techniques. The results showed that the engineered model performed better with the lower MSE and higher R squared. Sa baba, ayun, results. Sa results. This confirmed that the AI-supported feature engineering made a positive impact, helping the model learn relationships in the data more effectively. Tapos yun. Okay na siguro yun.